Everyone. Hello. Hello, everyone. It's about 7 o'clock, so we thought we might kick things off tonight. And big thank you for coming out for iwomm tonight. This is the 101 Ways Tech Club. This is the 4th event that we've done this year. It's in the 2nd year of doing them. And we've never tackled WebAssembly before, but it's particularly topical, isn't it, right now? And something that we're going to hear from 2 different people on. But you might not know about iwomm. So Tim's going to say a few things about iwomm.
Yeah, thank you. Thanks, Richard. So iwomm was born inside 101 Ways. It's as its tech members, we wanted a reason to meet up somewhat regularly and have a few beers, have some good food, and to share knowledge and war stories. And what we wanted to do is create an event, and that's what happened. It was an internal event, just private to 101 Ways for, like a year and a half, something like that. And we opened it up recently. So it's really good to see all of you here. We're going to keep it open to the public going forward, and the mission remains much the same. It's to share knowledge and provide a nice safe space to do that. Just good vibes, no heckling unless we know you, and we know Oren, so he's going to definitely get heckled.
Indeed. So just a few words about 101 itself. We're a product design consultancy based here in London with offices in Amsterdam as well. I'm one of the consultants at 101. I work here at Just Eat as an iOS developer. I've been placed here by 101. And we just took on our 101st employee, so that's a bit of big news for us. We're only a couple years old at this point, but expanding quickly, and with clients like Tesco, Elsevier, DAZN as well. And another thing that's important to mention is that we're always looking for submissions here, aren't we, at iwomm? And
yeah. So we've had various talks. So if you're like me, you've probably signed up to some meetup groups for specific programming languages, specific frameworks. So we're going to do things a little different. It's going to be whatever's hot, whatever we think is a good topic. So we've had, what have we done? We've done big data, we've done serverless, we've done React, cryptocurrencies, Commodore 64 emulation, and the demo scene. So, no topic is is out of bounds. So if you are interested in doing talks, we try and create that safe space for you. I think a lot of our members who will be doing talks in future are first-time speakers. So get in touch with Oren, Richard, or I, and we'll try and sort something out.
So, food competition. I'm sure you noticed all the bao upstairs. Hope you enjoyed them. We try to do things a little bit differently, as Tun was saying. Pizza and beer is just so mundane, isn't it? So every time we do one of these events, we try to pick a different food theme, and then one of the hosts, either Tun or me or Oren, Jamie, someone else, will pick 2 of our favorite restaurants in London and then kind of battle it out and see who comes out on top. We've done everything from chicken wings to burgers, even pizza, banh mi, gyoza, dumplings, and this time it was bao. And it's tough to find bao places that can deliver that many.
What is bao?
Well, bao are Taiwanese steamed buns, and I hope you enjoyed them. They're kind of on the up in London right now, aren't there? There seems to be a lot of bao joints opening.
Asian taco.
Yeah, an Asian taco. Yeah, that's a good way of putting it, Tim.
But Oren asked, what is a bao? It's somewhere between a slider and an actual burger. So
yeah, that's it.
Maybe you'll agree.
So now the most important thing is don't forget to vote. So I don't know if you notice the signs up there, but there's signs, and just grab a marker and leave a mark on your favorite bao, because we want to know what the best bao joint is in East London. Well, in Central London too. So at the interval, we'll all wander back up, have another drink before the second presentation, and don't forget to vote. I'll be sure to hound you about it. So over to you.
Thanks. Yeah, we need to know who the winner is tonight, so you need to vote. So there will be an interval, as Richard said. So we got 2 talks today. So Oren is up first, giving an intro to WebAssembly, and it's about like 20 minutes each of these talks, and then we're going to have an interval for about 10 to 15 minutes. And our second speaker, Carlos, who's going to talk about some practical applications of. So yeah, that's the evening. Yeah, sounds good. Anything else to add?
Only other thing to say is, if you want another drink, there's some downstairs here in the little cart by the stairs. Feel free to help yourselves. Yeah, that's it.
Awesome. Get up here.
Yeah, this should be recording.
Thanks.
Okay. Can you hear me?
Yes.
Hello. Wait. Okay. So I'm Odhrán McConnell. I'm the CTO of 101 Ways, and I'm going to give you an introduction to WebAssembly today. So I've got 2 machines here because we couldn't get the speaker notes up, so I have the speaker notes here, and I've got the presentation over here. Excuse me if this gets a little bit technical. But before we start, I've got a bit of confession to make. I'm not a fan of JavaScript. Never have been. So the fundamental problem with JavaScript is that it's a broken language. Right? The problems with it are well known. This one is my particular favorite at the bottom here. So there are two possible things that you can do about it. First is eliminate those problems from the language. The second is avoid the problems altogether. So how can you eliminate the problems from the language? You can't. ECMA will never make a breaking change to JavaScript. Right? So your only other option then is to avoid them altogether. So how do you avoid the problems? The only way to avoid JavaScript's problems is to avoid using JavaScript. This usually means using an alternative transpiled language, and there are way too many out there to mention. But fundamentally, as long as David Flanagan's book, JavaScript, the Definitive Guide, continues to teach people all of JavaScript's ugly features, we have a problem here. So, unfortunately for us, the problem is in the center of the web. You see, I feel sorry for Brendan Eich. He's the programmer who designed JavaScript. Apparently, it only took him 10 days. But I can imagine how those days panned out. So he was basically under the cosh of his Netscape overlords. He could have been rushed to deliver something by 9 a.m. Monday morning. Late nights, too much coffee, totally stressed. I can imagine this, and I bet you can too. That can affect the quality of the output, and I think we all know that. So our problem now is that those 10 days have culminated in JavaScript being the equivalent of the assembly language of the web. And this is not a good state of affairs. Thankfully, there's a potential solution, and that's why we're here today. So I'm going to try to convince you to adopt WebAssembly to build your own web applications. So how am I going to do this? Firstly, I'm going to try and give you an understanding of WebAssembly. If you understand it, maybe you can use it. Then I'm going to tell you why you'd want to use it. And finally, how you can get started with it. So this is going to be a quick talk, about 15, 20 minutes, because then I'm going to hand over to my good colleague, Carlos, who is going to show you some of the practical applications of this technology. And let's be honest, that's going to be a lot more interesting than hearing me speak. So with that in mind, let's be, oh thanks. I get my coat. With that in mind, let's begin. What is WebAssembly? So in a nutshell, I believe it's the future of web development. First, it's a new language. WebAssembly code defines an abstract syntax tree, which is represented in binary format. This converts neatly into a text format, so it's human readable, writable, and most importantly, debuggable. Second, it's a browser improvement. So browsers will understand the binary format. This means that we'll be able to compile binary bundles that compress smaller than JavaScript does today. Smaller payloads obviously mean faster delivery. Depending on compile time optimization opportunities, WebAssembly bundles may also run faster than JavaScript too. So all good things. Third, it's compiled target. And I'm going to make mention of this later, but that's really important. It's basically a way for other languages to get first-class binary support across the entire web platform. So I think that's good. I want to talk about the benefits now. So first and foremost, it's fast and it's efficient. The WebAssembly stack machine is designed to be encoded in a size and load time efficient binary format. So WebAssembly executes at close to native speed by taking advantage of common hardware capabilities available across a wide range of platforms. So if you've got the latest NVIDIA GPU, then you'll be absolutely cooking in terms of execution speed. Next up, it's safe. So WebAssembly describes a memory-safe, sandboxed execution environment that can even be implemented inside a JavaScript virtual machine. It also enforces same origin and permission security policies of the browser itself. So you're not losing anything by coding in WebAssembly. It's open and debuggable. It directly translates into human readable text. You can view the source and still read it. It's early days, but the latest browsers are able to debug WebAssembly. And as time goes on, these tools will only increase in power. So finally, it's designed to maintain the versionless, backward-compatible nature of the web. WebAssembly modules are able to call into and out of the JavaScript context to access browser functionality through the same web APIs accessible from JavaScript. So good interoperability. So what does this mean for JavaScript? Well, before I answer this question, I want to back up for a moment. I want to take you back in time. Back before Node and React, before Backbone, before jQuery. Now skip back a further 20 years into the past. The year is 1984. I'm a young 11-year-old learning how to program and how to program games on my Commodore 64. I started off with BASIC. Very easy to learn, and it allowed me to wow my family with all little neat tricks and graphics. I could show, neat tricks and graphics. But there was a problem. It was slow. It was very, very slow. So BASIC is a scripting language. And with any scripting language, it's first interpreted line by line, then just-in-time compiled, then finally executed. So did I mention it was slow? It's very slow. It quickly became apparent, though, that if I wanted to do anything decent, then I'd have to learn how to code in assembly language. Sometimes you need to get to the bare metal, or at least as close to it as possible. So fast forward to today, and the same principle applies. Just because our programmers can handle it doesn't mean we have to be lazy as developers. Let me be clear. I'm not arguing for people to learn how to code in raw WebAssembly. Right? That would be nuts. I'm simply saying that the machine code of the web should actually be machine code. So why would I want to use it? Because it's the right thing to do. You guys are loving this. Shut up. We need WebAssembly because as flexible as JavaScript is, it's still too hard to express many things in JavaScript. WebAssembly gives us access to a set of low-level building blocks that we can use to construct just about anything we can imagine. So the keywords there are low-level. It defines primitives, including a range of types and operations on those types, literal forms for them, control flow, calls, a heap. So these are very simple primitives, nothing fancy, no complicated object system, be it prototypal or otherwise. No built-in automatic garbage collector. It's really simple, but I think that's a benefit. So let's take a look at some of this. There you go. Here we go. Oh no, sorry, I've skipped forward a bit. Excuse me. Right slide. You see, I told you this was difficult. So let's take a look at some of this. So WebAssembly encodes bytecode instructions which have opcode names, right? And just like in normal assembly language, the format is the simple opcode operand per instruction. Each opcode, for example, get local, translates directly into a binary code, in this case, hexadecimal 20. So let's talk about the structure of WebAssembly. So, I mean, this is a simple example. I'm not going to go through it, but the thing that I want to get across is that each one of these text opcodes equals a binary code. So WebAssembly has 4 value types. It's got 32-bit and 64-bit value types for integer and for floating point rather. And as with any machine, we need memory. So in the case of WebAssembly, we use what's called linear memory. Linear memory, it's a contiguous byte addressable range of memory spanning from an offset of 0 and extending up to varying memory sizes. But the key point is the size is always a multiple of the WebAssembly page size. And the WebAssembly page size is 64K. So you can go up in multiples of 64K. So the memory size can be increased dynamically on the fly and use the grow memory operator to do so. And this will increase its page size by a further 64K next time. So memory is also an array of bytes, and as such, it's actually sandboxed. So think of it as just an array. It doesn't access other linear memories, so it's safe in its own context. It doesn't access other linear memories, the execution stack, local variables, or other process memory. So how do we access this linear memory? We got a set of opcodes, as you do. The pattern here is that each opcode addresses a 32 or 64-bit integer or floating point again, and load is the opcode. And here's a set of store opcodes. Exactly the same pattern applies. We can get and set local variables. So variables, I mean, since when does any assembly language have variables? So each function, when you write a function in assembly, each function has a fixed pre-declared number of local variables that occupy a single index space, which is local to the function. So parameters, for example, when you pass a parameter into a function, they're addressed as local variables. And local variables do not have, memory addresses per se, and are not aliased by linear memory. So they're literally just in their own right. Global variables, same applies for this, but local global scope. Control constructs. Okay, so we got some control constructs. Simple, obviously, no op. Everyone knows op. We also have some branching and a little bit of comparison, if else, return and end, obviously. We got some function calls. So you can call indirect. So each function has a signature, which consists of a return type and arguments. Right? So that's the signature of a function. You can call them directly or indirectly. The difference with indirect calls is that it's a dynamic comparison as opposed to a static comparison. So it works out what the function signature is on the fly as opposed to having it told to it. By the way, I did say this was a tech talk, right? I hope you're all expecting that, right? Next up, we got some operators. So these are clearly very handy for the day-to-day stuff that every programmer does, such as addition, subtraction, multiplication, rolling. So we can see here the programs are made up of the normal parts you'd expect from a low-level language. And more importantly, a compiler can be easily tuned to produce this binary format. So this makes so much sense because it means that we can actually get back to the normal pattern of developing software. You write in a high-level language, you compile directly to machine code, and you execute. So this pattern has been missing from the web for way too long. So could I use it today? Absolutely. As of today, 75% of all users globally have WebAssembly support. This is quite significant, considering it's so new. There is a way to go, but if we ignore IE, Opera, and other browsers for Android, then that percentage is actually quite a lot higher. So yes, you can do it today. So what's the catch? Nothing that can't be overcome easily, I'd say. So right now, the biggest barrier is compiler support. LLVM, in the shape of mscripting, is the only compiler to fully support WebAssembly. This means that you have to code in C or C++ at the moment, and then compile it to WebAssembly. But that's not the end of the world. I mean, when you think about it, there are literally thousands, millions of libraries for C and C++. So you can easily find the best way of doing something. I would say learn by example and practice. But one of the best things about WebAssembly is that it's easy to express things like threads and SIMD. So SIMD is basically a fancy term that means you can line up multiple chunks of data next to each other and evoke a single instruction to operate on them all at the same time, rather. So it means a single instruction, multiple data. What that means in reality is that you have fat parallel processing pipelines for your real-time video stream effects processor, for example. If you have your finger on the pulse, you will already probably heard that there's people doing this in JavaScript. But I would say it's quite awkward to try and do this low-level stuff using JavaScript's existing type system. There's too many exceptions you'd have to make. So how do I get started with it? Okay. Download a compiler and start coding. There are some great examples out there, more being created every day. Carlos is going to show you some great examples in a few minutes. And let me conclude, because I did say this was a quick talk, but let me conclude by saying that I believe this is truly a revolution in web development. JavaScript has served us well over the years. There have been some notable enhancements that have given us the web we have today. Most notable probably is XML HTTP request. Without this, we wouldn't have the single page application. And unbelievable as it might seem, actually, you have Microsoft to thank for that. So I digress. JavaScript, I salute you. You've had a great innings, and you've made the web what it is today, warts and all. But it's time for a change. And that change should be WebAssembly and the possibilities it gives us. Thank you very much. Yeah, let's answer some questions.
Yeah, well, thanks for that, Odhrán. We can take a few questions if anyone's got some. Yep, right over here. Why don't I bring the mic to you? We're just recording this, actually. And,
so hang on. We have the... yeah. We have this, and we can turn on 1, 2. Okay, so you can go with that, and then I'll...
yeah, sorry. Yeah, how does it do I/O? How do you do the I/O? You talked about the hardware, generalized hardware, but how do you actually do the I/O?
How do you do the I/O? That is a question that this chap over here is going to talk about. Yeah, I'm setting you up here. I'm setting you up for a fail. Basically, as with standard C libraries, for example, if you want to output some text, you just do a standard out, and you know, that's the way to output text. You can hook into graphics libraries, so there's loads of graphic library out there. WebGL is a common one that people use to hook into. Unity have also developed that, so if you want to output graphics, you can use those libraries in the normal way. Basically, if you've got a C library or C++ library, you can compile it down to WASM.
Cool. Any other questions? Yeah.
I didn't get if you were saying that we should program directly in WebAssembly or use a high-level language and compile to WebAssembly.
I did try to make the point
okay.
that that I'm not advocating for people to code in assembly. All right, I'm not advocating for that. All I'm saying is that the machine code of the web should actually be machine code. All right.
Okay, let's use this.
Yeah, thank you. So you mentioned the linear memory model. So I suppose that opens up the linear memory model.
Oh, yeah.
Since there's an MMU involved somewhere there. And with that, another class of problems that the current web has forgotten about like heap fragmentation and all those good bits, how long do you think it will take the average, the super average web developer to learn those things and work around them?
That's a great question. Okay, so let's talk about your average web developer. I mean, your average web developer nowadays will be using JavaScript in form of Node to code for the full stack. So I mean, there's a lot of good developers out there. I would say that there's a way to go before we get better language support for WebAssembly, because as it stands right now, you got C and C++. That's really not good enough for your average web developer. They're although they're high-level languages in the strict sense of the term, they're still pretty low. So my hope is that language vendors will get on board modifying to pick up on compilers, or to build their own compilers so that they can compile down to WebAssembly. That'll take a while. I don't know, maybe years. I hope it's months. I doubt it. Ken.
Dumb question. So this runs inside the browser, which runs inside an OS, right? So how, I mean, JavaScript, it runs inside the browser's V8, the JavaScript engine, then inside the browser, which is then inside the OS. How is WebAssembly in that stack?
Mm-hmm. Okay, so although you use JavaScript to load the WebAssembly binary, it does load into its directly into the browser virtual machine. So yes, you're right. There are layers in there, and it's basically the browser is one of the layers. You're skipping the JavaScript layer. Okay, so it'll run natively within the browser, which then has access to the hardware access layer and all those good things. So there are still steps that it needs to go to, but that's what I said, close to native.
So it is still inside the browser sandbox as as any other language.
Yeah, exactly. Yeah.
But at least it doesn't have to go through one additional script interpreting layer.
But when you think about that script interpreting layer, that's an expensive layer.
Yeah.
Okay. Any more questions?
Hello. Pass it back. Be careful of the lights.
Oh, thank you. Well, actually, he asked pretty much identical question to what I had. But, so carrying on from that, so if it is running in a VM essentially in the browser, what prevented us from transpiling JavaScript down to, say, like a low-level assembly language and just carrying on using JavaScript?
You're a JavaScript fan.
No, right, okay. So, on the record here, yeah. I was just talking to Tun about actually how I hate JavaScript. So that's why I've come to this presentation, because I can't wait to get rid of it. But are they already doing TypeScript to WASM?
Are they already doing TypeScript to WASM? I heard something about that somewhere.
You might be right. Yeah, I have heard rumors of that, but I haven't seen it in action.
Right. You can have this back.
Yeah, TypeScript, CoffeeScript, that side, yeah. Whoopsie daisy. So you had a question there, or was it the statement?
No. It is sort of a question. What prevented us from compiling JavaScript down to some kind of assembly language like that?
Yeah, you could do. Yeah, I mean, there's no reason why you can't use JavaScript as that high-level language. I think that the problem with JavaScript really is JavaScript's VM and how it interprets types, like the examples I showed you at the beginning, and all of the other problems. I didn't even mention the other problems that there are with JavaScript. So yeah, you are right. If you use that as your high-level language, then great. But I would argue that a language that literally has those 5 types, what is it, number, object, not number, undefined, and something else.
But I think more the pertinent part of that question was, would you gain a performance boost from doing that, or would there be no real benefit?
if it's still compiled to WASM, probably.
I would say that's literally what the browser is doing now.
Yeah, I guess, yeah, so in its own VM.
Yeah, exactly. I mean, over the last 5-6 years, maybe a bit longer, all the major browser vendors have spent a lot of time gaining access to the hardware access layer and the acceleration that you can have from directly using that hardware and giving that to the JavaScript virtual machine. So they have already done that, right? So that's a given. But there's a step. Yeah, exactly. You just said it. Just in time. It's just in time compilation as opposed to pre-compiled.
Okay, so that's probably a good time to call quits on your presentation, Oren. But thanks very much. That's great. Cool. And now we'll just take a short interval of maybe 10, 15 minutes. Go grab yourself a drink, some more food. Don't forget to vote on your favorite
You have
bow.
to vote.
And when we get back, we're going to have a presentation from Carlos, and he is the guy that created the WebAssembly logo. And he's also the head of the WebAssembly London meetup group, so he's a great guy to talk to if you want to know more about WebAssembly, and we'll hear from him next, Practical Applications. Is that? Ah, well, you too.
No, I mean,
yeah, I got too much for this hat. Where can I put this?
yeah. Hello, hello, hello. Does it work? Does it work? Can you hear me?
I can.
Speak.
Hello? Yeah, you're good.
it's more or less about sort of like from the VM browser.
Yeah, I think that's what I had first time round. It's good. I couldn't figure out how not to make it explode in my face.
They were the ones who killed all of the other sandbox style experience. I think they're just giving support to convert stuff. So all of the old content, all of the learning content, not yet ported to ActionScript. ActionScript is actually, it's got a runtime capability. So you can actually convert ActionScript to the VM and then compile. So literally you can actually basically so I used to work on and then they used to all of the stuff that's built on the Flash. So all of their learning experiences, the games they built for children to learn how in schools like that. Did you end up finding why we were doing it this way?
What, you really set up this time? Yeah. Yeah, so you're just like, I'm gonna go all the way to the back now. So nobody bothers me. Huh?
Hello.
Oh yeah, just get it ready. You know? Get it ready for it right after. We all get how about we all get a question ready for Q&A when Carlos starts? Hello. Are we live? Yes, perfect. All right, so welcome back. Hope you enjoyed some more bao and some more drinks. And I've got some news. We have a winner in the bao competition, and it is definitely not Tun. It is Yuu Kitchen, the buttermilk chicken bao. That's the winner. So thanks everybody for voting. It means a lot. And as our second speaker tonight, we've got Carlos Baraza, who's going to be talking about practical applications of WebAssembly. So can't wait to hear it. Over to you.
Yeah, awesome. Can you hear me? All good?
Yeah.
All right, so I'm gonna present. I actually really like starting with quotes because they make me look intelligent and smarter than I am. So yeah, there's this quote saying real programmers can write assembly code in any language. That's a kind of a like tongue in cheek on the cheek kind of like joke that Larry Wall used to say, and I think it's becoming kind of true. Well, so it's kind of cool. So well, about me, I am Carlos, and I'm a boat captain. Not even kidding. Like I had my license last week. Yeah, I mean, seriously. I am Carlos, and I am a software engineer at 101 Ways. So currently, we are one of our clients is DAZN, and so DAZN is kind of like a Netflix for sports in a way, and they really care about performance. And that's in a way I kind of thought about this WebAssembly because there's a potential application on that, and especially because of the player, all the streaming and codecs. There are many things coming in there. Yeah, so what is my relation to WebAssembly? So I actually designed the logo as I was presented, and I didn't even know that like WebAssembly would become the thing that is kind of becoming. It's pretty cool. Yeah, so that was a long time ago. So yeah, back to the presentation. So 74% of the browser support for WebAssembly at the moment. It's a pretty good number that actually a year ago wasn't like that. And it's just amazing that all the browsers have shipped that. And it's just becoming really cool. And especially if you are in the UK, like for some, it's actually an 80%. I mean, sadly not Internet Explorer 11, but you know, I mean, really, are you developing for Internet Explorer 11? It depends. Maybe you are, but and the cool thing, well, then so can I use it today? I will say you totally can. Like it's really, I'm really certain about that. And you might think why? And I think the reason is AwesomeJS. So is that there is this 20 last percent that you potentially could miss if you are adopting like WebAssembly. But the cool thing is that there is a backup, so you can still compile to AwesomeJS. I will explain what AwesomeJS is later. So I will probably first talk about like some applications. So what I guess the direct thing, the cool thing that everyone uses WebAssembly or any kind of tool. I would say that always the games, they go far before than the rest of applications because it's really demanding. They are trying always going to the cutting edge. So I will show a few examples of that. For example, the Unreal Engine 4, there is the full Unreal Engine 4 actually released for WebAssembly. I'll have a demo for that. So I have it already loaded. It probably is laggy. In my machine looks very smooth. But the thing is that because the streaming thingy, it becomes kind of slow. But that's actually the full. It's really like nice graphics. You can interact with it, so hopefully this stops moving. But yeah, you can interact with the thing and do. It's just pretty cool. Like, and the graphics are amazing. Like maybe you don't realize there, but it's really good. Like, yeah, you can interact with the thing. So because. All right, so that's one of the demos that I wanted to show. Yeah, so it's really cool. It's just the full Unreal Engine. It's just amazing. I don't know if you ever use that, but it's a really nice tool if you're building like some sort of like 3D experience. Yeah, probably the downside is that you are not loading all the assets and all of that. So yeah, maybe. So yeah, these are just some examples of the same thing. Then, of course, Unity, which is the main competitor of Unreal Engine, they did the same. And I think I have another demo for that. So this is actually the Unity one. So you can just move some tanks and whatever, just play some game. I actually you can move it as well. I'm not sure how to fire though. yeah, whatever. Anyway, so then so back to that. Maybe, I don't know. No, not definitely with my machine. It's an old MacBook and not necessarily that powerful. I mean, I would say that yeah, it's got a GPU, but the GPU that it's got is like one of those integrated like GPUs, and it's not really that good. Yeah, some other really cool applications of that is that you have really old libraries. Like for example, Bullet is like a really nice physics engine that was built for C++. And the cool thing is that now you can port them to WebAssembly. And I also have a demo for that. Sorry about that. So this is just a demo with the ammo they call it. And yeah, it's just basically lots of boxes falling. But yeah. Yeah. The funny thing is that it's kind of broken this thing, and it just doesn't work. I don't know why, but it's just it's broken. Yeah. So yeah, that's so Bullet. And the cool thing is that this is not only applicable to games. The games are definitely the first ones to adopt that because they're always looking for new technologies, for new things, so they can get more market. And yeah, so but for example, there are really old applications like AutoCAD that they have like 20 years plus experience developing that. So there's lots of code there, and there's lots of experience on that code base. So for Autodesk, it would be like really crazy trying to like totally scrap that and deploy a new version of that just made on JavaScript. So what they did is they poured the whole thing from the C++ code base that they have to WASM, and this is actually deployed. It's deployed, and you can use it. And I think it's the only browser the only tool that can open that DWG, they call it, the extension, because it's just really difficult extension with really bad documentation and yeah, proprietary thing. Yeah, also you've got Qt. I don't know if there's any C++ developers here. Oh, awesome. Cool. So you've got Qt as well, which is a UI library for C++. It's not that I don't know much about C++, so don't judge me on that if I say something wrong. So yeah, so Qt has got a lot of examples on how to compile Qt to WebAssembly and deploy that. And for example, one would be having like a text editor there. Yeah, it's a full text editor written in C++ that is running on the web. Even OpenGL, like you can compile like OpenGL shaders directly to WebGL shaders through WASM and all that. So it's pretty useful. As well, even I guess there are many Node developers here, right? Definitely Node developers. Yeah, cool. So, but when you do npm install and you download, I'm sorry, by the way, I'm a JavaScript developer. I know that he said he doesn't like JavaScript. Yeah, so Node, when you do npm install, you have some of the dependencies that you have, they need to compile to your platform because you're running the binaries. One cool thing that you could do with WASM, because WASM is implemented on the virtual machine and on the actual engine, the JavaScript engine, that means that you have WASM in Node as well. So if you wanted to, you could actually run a WASM module directly in Node. So you could compile your C++ library to WASM and then just ship that. And you don't need to ship anymore like the source code of C++ or whatever and try and get everyone to compile that to their platforms. So you have a common module that will be used for everyone. And that's, I don't know, for me, that's pretty cool. Yeah, one example of that would be libsass. So if you use Sass at the moment in Node, that is pretty is really used at the moment. If you're building like a single page application, most likely you are using Sass or less for your styles. So Sass is actually a C library, and well, it's not originally, I think it's Ruby or something like that, I'm not sure, but they ported to C, and that's the one that is using Node. Yeah, so basically you could use that in WASM. Well, I actually started thinking about some crazy ideas about the uses of WASM. I thought that, for example, Chrome is is written in C++. So you could run Chrome in Chrome and Chrome in Chrome and Chrome in Chrome and have the sort of, if you wanted. And something even cool that someone actually did is that they wrote like a RISC architecture there for like a small architecture, and that on top of that they actually run the Linux kernel, and then well, then not necessarily, but they run a kernel, and then on top of that they run Windows, and they basically you can run Netscape in Chrome or in Firefox with that. So the original one, I think, yeah.
Is Netscape running JavaScript or the original Netscape?
And that's a good question. Most likely. Yeah. It is actually a 3D environment that you can interact with. I will not show that because it's a bit buggy in my machine. But yeah. Then something I tried the other day is like running this guy that wrote something similar to what I said. And then you can run BCBox, which is a very simple like Linux. Yeah. And you can run BCBox on that machine. And for example, you could compile like C into that weird invented architecture, and then run your C code within that architecture. Like there are some crazy ideas that you can develop there. I even thought that you could potentially do like Docker, compile the whole Docker thingy into, and then run Docker in your browser. Why not? I don't know why would it be useful, but yeah. Then yeah, so some tooling. I think the most important thing to understand about WebAssembly at the moment is that you've got like your front-end code base, whatever it is. In this case, it's C++. And then you have the LLVM intermediate representation, and then you have ASM.js, and then you have WebAssembly. Now, this is kind of temporary. Like it's there now because it was the original project was actually to compile from C to ASM.js, and then this came in, and they thought that would be easier to do that. But there is actually the works of creating a proper backend for LLVM, so you can have the WebAssembly as a proper backend of LLVM. So for this whole thing, there is a tool called Emscripten, and so Emscripten is just converting like LLVM intermediate representation to ASM.js, and that's the compiler. And you might think that. But so what is LLVM? Does everyone know what LLVM is? I think I'm not sure if it even stands for like virtual machine. I think it's not an acronym even. Well, is it? All right. So there you go. So yeah, basically it's a collection of modular and reusable compiler and toolchain technologies used to develop compiler frontends and backends. A compiler frontend, everyone knows what it is? All right. So just to clarify, frontend will be your language thingy. Like if you have C++, otherwise, or JavaScript or whatever thing that you want. And the backend would be the actual machine code usually, or something that you are, and it could be multiple things. So in the end, like LLVM stands in the middle between your language and whatever thing that is actually running on the platform that you're running. And that's the cool thing. It's sort of doing the same thing that like JVM with bytecode and all of that, JVM. Yeah, so ASM.js. ASM.js is a subset of JavaScript, and with that, what it means is literally taking the cool, the useful things about JavaScript. So not the weirdness, the weird things that that were created with JavaScript, and basically compiling your language into those. So only using those small things and using like the binary parts of JavaScript and not the weird parts, sort of, to put it in a way. So what does that have to do with WebAssembly? Is that then there's a tool called Binarian or whatever, I don't know how to pronounce that. And that tool is just converting ASM.js into WebAssembly. And yeah, again, so LLVM there is a backend for LLVM that is being developed now. And it's actually experimental, you can even try that. So supported languages, I will defer on what you said. So C and C++, definitely. That's the most mature kind of path that you can go. Then you have Rust. So it's Mozilla's baby. They have been like kind of petting that for a while, and they're trying to push it a lot. And so they're giving like really nice support for WebAssembly because they really believe that WebAssembly will be the future. And same for Go, because it's kind of trying to compete with Rust. They have that kind of weird thing going on. And yeah, so both, actually, I'm really excited about the one of Go because they build for the next version of Go, which is coming, I think, in a week or 2 weeks. And they are releasing full support for WebAssembly, which is really cool because they build all the libraries to connect your so your JavaScript. Because at the moment, like WebAssembly is kind of running in its own module thingy, and you don't have access to all the DOM and the nice cool web APIs that we have in JavaScript. So the cool thing of Go is that they are building those interfaces and all those bridges between WebAssembly and JavaScript. So you import the JavaScript that Go provides you or whatever, or they actually generate for you, and then the WebAssembly part, and you can basically build your entire thing in Go. So you could build potentially, let's say, React in Go, and in fact, it's actually done already. I think there's already a project for that. Yeah, and in fact, you can actually convert pretty much any language that, I think, any language that has an LLVM frontend, you can use it to compile to WASM. And at the moment, you have like ActionScript and that shit, like pretty much all of them. Like all the languages that are pretty mature, they have a compiler to a frontend for LLVM. So yeah, I mean, there's a catch there. Is that some of the languages they require the interpreter, and there are many cool like things that they provide you, and you will need them as well. So if you're shipping, let's say Python, you will need to ship as well all the runtime and all that kind of thing with it, unless you do some sort of magic for that. Yeah. Show me the code. So I'm using a Docker image that is around. I built my own first, but then I realized that some guy did it before, so it's just better to use someone else's thing. So how it works is MCC is encrypting. That's the tool actually that allows you to build your C++ into JavaScript or WASM. And yeah, you pass your C++ code and you get a JavaScript and a WASM. It's kind of, even if you don't put it there, it actually generates a WASM file as well. Yeah, I'm gonna do that, hopefully. So yeah, I wanted to go through the code, like actually writing it, but I think that I don't have enough time, so I thought that it would be better to just like explain what I'm doing. So yeah, basically initially this is a C++ hello world like file, which is including the library IO stream, and then I'm just creating a function, main function. Can you see all, by the way? Yeah, cool. Yeah, in the end, I'm just printing that to a standard output. And yeah, so I'm gonna just show you how I run that. So terminal. By the way, so yeah, yeah, better I will show. So do you know how packaging script work? It's basically sort of like make. So if you're, in a way, what I'm gonna just say is, I do npm build, and then that will actually run this command, which is I could run the command directly. You know, better I will do that actually. So if I wait, I'm gonna I'm gonna go to hello world folder, and then so if I run the command, so docker run, and I'm just setting basically the whole initial part is not really like needed. All of the most important part is all that comes after this. So then it's basically what I say. The closure part is just kind of telling the browser to optimize, not the browser, the compiler to optimize the JavaScript resulting, or the yeah. So that takes a bit of time, and then after a while, it will generate this WASM file and these JavaScript files. And you know, for the sake of trying, I'm gonna change this. And I will say, so iwomm. So if I run it again, so yeah, I have an HTML file that I will open. The HTML file is literally getting the script, the hello world JavaScript. The hello world JavaScript will actually download the WASM as well. And yeah, just execute that, just literally that. So I'm gonna run a web server that is just serving the entire folder to make it. I cannot see my screen. I cannot see. Sorry for what's bugging that. So that's running now. Just a simple. So if I open that, oops. Yeah. So you get hello. I won. Oh, that's a funny one. Hopefully. All right, you only 300K for Hello World. I think it's fair, right?
Well, that's good considering that Hello World included the libc.
Yeah, includes many things as well. That's the thing. So yeah, it's that's kind of the trade-off that you have when you're using these kind of tools. Yeah, so I'm gonna do back to the presentation. So yeah, I have the backup plan there in case that something didn't work. Yeah, I'm gonna actually now build a small module, like a WASM module, and see how that goes. So the module is, in this case, math. So because it's a potential use case of this, is like there are some really nice math like libraries in C++ that you could use, and they're very optimized, especially like to work with matrices and stuff like that. So the C++ file, again, there's only one file. There is an HTML file that is loading and doing, the HTML files are doing a bit more, but I will show you why. Basically, this is just, I'm importing the whole math library from C++. Then this extern thingy is because you don't want C++ compiler to start messing up with the names, and because you're going to be exporting the name of the function, it's kind of required or recommended to do that. Then so I just create a function called float square root, and it was going to return me a float, and it's going to receive a number float in, and I just return the square root imported from the math. So the index, what it's doing, this is doing a bit more things. So yeah, there's some styles that I just hide, that's not really needed. And then there's a body and a form. So the form is just having an input in the middle that is just saying the square root, and I'm just going to introduce the number there. And a placeholder for the answer. Then I load the JavaScript file that is generated. And I use this function that is kind of generated by scripting that allows you to kind of wrap the C++ code into a JavaScript file, a JavaScript object. Yeah, you pass the inputs the types that you are expecting, and yeah, that's a function. And in the end, I'm actually getting the document question, adding the event listener for when I submit the form, prevent default, and I get the number, and then I just calculate the square root here. And yeah, I do some magic here in case that the number is 42. And yeah, I just print the answer there. So if I do the same thing, so I'm not sure why it's lagging there. Can't respond. Oh, sorry. All right, so if I do the npm run build, I will show you because I did a bit weird thing here, a bit of a different thing. So you need at the moment to declare what functions you're exporting. And there's these extra ones that I'm going to call the surwrap and the ccall, just helpers. So yeah, if I run that command, it will run the whole thing in Docker, and it will generate me the math WASM and the math.js. I will show you what the math.js has inside after that. I will first show you the result of that. So npm start. This is just because it's cached. All right, so I've got that input. So if I put, let's say, the square root of 4, it should be 2. The square root of, I don't know, like 21 should be, yeah. So I could do like the one that I was planning is 42. Yeah. And yeah, so the JavaScript file is generated with lots of things inside. I mean, you can go through it, but it's basically manipulating all of that, all the inputs and outputs from some of the helpers that are required to actually interface with JavaScript. And you can complexify that as much as you want. It depending on what libraries you need. If you need like WebGL, this could become even more complex. Yeah, that's the kind of thing that Go is doing or Rust are doing. So they're kind of generating that JavaScript for you, so you don't need to even do that. And yeah, again, actually, just for out of curiosity, I want to check what is the weight of this because I didn't check. Oh, it's actually better than the Hello World. Nice. It's 21 kilobytes for the WASM. Actually, JavaScript is way more. Yeah.
Also the conversion of from binary to string to binary. So you can do anything with strings in WASM.
Yeah, as well. Yeah, good thing to know actually. Now back to presentation. Oh yeah, back up. Oh yeah, I wanted to say that I actually started the WebAssembly meetup in London, and that should be at the moment. I'm pretty excited about that because we've got already like 80 members, and I literally started like I don't know, a week ago or 2 weeks ago, and it's just amazing that 80 people already subscribed to that. Yeah, so feel free to join, and maybe there will be another. Yeah, definitely. Actually, we should totally do this talk again, at least to. Yeah, and yeah, thank you, and yeah. Do you have any questions?
Yeah.
I remember Google tried something similar to this called the native client a couple of years ago, and that failed. Do you know why?
I think the reason is because that wasn't a standard. That was something that Google tried for their extensions craziness, and they wanted to allow you to build more like native kind of thingies for the extensions of Chrome, and it wasn't adopted by other browsers, so it kind of died because of that, I think.
Okay. So then, what is the standard that is being adopted here?
So WebAssembly is the standard.
Okay.
It's definitely a standard. Like it's worked by all the browsers together. So it's properly adopted. It's not like you don't ship things to all the browsers without a standard. Like it's difficult to do that.
Any more?
Yep. Because you have the Unreal Engine demo, do you know what's the frame rate of that versus running on the
Which you mean
any of the 3D demos? I mean, if there's a FPS on that versus what it would do on your machine.
I can, in my machine, I will tell you what it feels because I did some gaming, and it sort of feels like 40 frames, something like that. And it's a really bad machine. Again, that may be a demo. Maybe with a real game with real like more complex shaders and all that kind of thing, it can become maybe it's not that good. Like I would not say it's probably not as good as DirectX or something like that.
Yeah.
But it's still like it's slowly getting there, right? It depends on what kind of thing you're doing, right? If you're doing just AutoCAD, it may be enough, and still you can provide lots of value to the people, your users. So yeah.
And it can only get faster, right?
Yeah, exactly. It depends. It mostly depends on WebGL. In the end, this is interfacing with WebGL. So it's as fast as WebGL can be, right?
Next question.
Not really a question. It's more pondering. Wonder if this will transform the landscape of software as a service. You just log on to your Adobe AutoCAD account, the application runs in the browser, you never run it on your computer ever. So best case scenario, you have some cached objects in your browser. Yeah.
Yeah, why not?
Yeah.
I think that was the idea behind the commons.
Right.
Yeah, I mean, Google is pushing a lot for that. So, you know, if they want to do that, maybe that's all of us will do. I don't know.
So what you're telling me is that we shouldn't have got rid of Java applets because they were way ahead and light years ahead. But serious question. You said that Go has bindings to the DOM, so you can actually do things in the DOM. Does C++, are there any C++ frameworks that allow you to do the same?
I'm not sure if there are some libraries. I didn't check that much. But I didn't try to do web development with C++ because I'm a JavaScript developer. So I will do it in JavaScript because it's what I mostly do. But you can do it. Like there is no way. Why wouldn't you? Like it depends. I don't know if they are already available. Some libraries, but they definitely you can make one.
Because I would love to see these high-level frameworks do that. Because I have one fear at the moment is that we're going to end up with all custom user interfaces because people will just literally port desktop apps with their own user interface into the browser, and then we'll end up with like really fragmented UI, kind of, because it won't look like a website anymore or a single page application. Exactly,
Yeah.
that's what scares me. But
yeah,
I mean, I wouldn't. In terms of games, right?
Yeah, honestly. Yeah, I don't think I wasn't really when I saw like the Qt interface. I had some sort of like feeling like I didn't really like that honestly. But it's it's just another possibility depending on what you're building. Like the fact that you are doing ugly UIs, I think that's a different thing. That I think that the whole like design ecosystem has evolved a lot since the 90s and I think back in that time, like it was more important about getting something practical, and now there are other use cases, and people try to build more, like I don't know, nice UIs and UX.
You see that, but then there's still applications like, say, for example, Steam, which doesn't scale nicely on 4K displays. So many applications like that, and the thought of that then suddenly entering into the web is kind of alarming. But
yeah.
You have that possibility in HTML and CSS as well, that you can create any such sort of interface. But that comes like flat UI or material theme, you just don't do that. You know that not to look bizarre or awkward. I think the same applies in this case as well.
Yeah, exactly.
Cool. Next question. Anyone else? No more? No. Okay. Well, thanks very much, Carlos.
Awesome.
That was really interesting.
Thank you.
Lots of action.
Cheers.
Cheers.